When governments pass new laws or launch social programs, we need a way to prove those actions actually caused a change. For decades, the standard tool for this has been a mathematical engine called two-way fixed effects, or TWFE. But recently, researchers realized this engine was producing backward answers. The model was generating something called negative weights, essentially comparing groups that had already received a policy against those that hadn't, leading to incoherent results. The response from the scientific community was a decade of intense repair. Econometricians developed an array of complex mathematical patches, new estimators and weighting corrections, meant to clean up these geometry errors and restore confidence in the numbers. Yet, even with these sophisticated fixes, a massive reanalysis of the field shows that the results are still often indistinguishable from zero. Despite the new math, the engine is still failing to produce reliable truth. A 2026 study by Chu and his colleagues re-examined 49 published papers using these state-of-the-art mathematical corrections. They found that the new, robust estimates were nearly identical to the original, supposedly broken ones. This suggests the field was looking at the wrong part of the machine. The technical adjustments didn't change the outcome because the underlying issue isn't a simple calculation error. The discrepancy comes down to how the model interprets time. There is a conflict between the statistical structure researchers use and the actual history they are trying to analyze. The crisis persists because these models were designed to process data points as static entries, rather than events that accumulate and change over the course of human history. To see why the math is struggling, we have to look at how the TWFE model actually views reality. It does not see history as a flowing sequence of events. It sees a flat, geometric spreadsheet. The model operates through variance decomposition. It takes a massive block of data and chops it up to remove the average differences between various groups and time periods. Here, time is just a categorical coordinate. It functions as a dimension used for indexing, rather than a forward-moving force. The model partitions the data into orthogonal blocks, leaving behind a flattened, static projection where all points exist simultaneously on a grid. TWFE has no internal theory of how one year leads into the next. It is a tool built for geometry, not for the directional movement of time. Because the model itself is static, researchers have to add an outside assumption to claim that one thing caused another. This assumption is known as parallel trends. Parallel trends requires that if the policy had never happened, the treated group and the untreated group would have continued to evolve along the exact same path. We see two flowing trajectories. The blue curve represents untreated groups. The solid red curve is the treated group. We use the blue curve's history to guess the red group's future. This dashed red curve is the counterfactual, assuming we swap one's future for another's. This creates a direct contradiction. Parallel trends assumes history flows like a river, but the TWFE model only has the properties of a static grid. For this to work, history must be recursive. Each period needs to be a clean reset, where the environment remains identical even as subjects change. It is the logic of the movie Groundhog Day. The math works because the world resets every morning. Phil Connors changes, but the day does not, making every iteration perfectly comparable. But political history doesn't reset. Human systems accumulate changes. Wars, institutional reforms, and strategic adaptations leave the world in a different state, breaking the link between the past and the future. When we force these messy, evolving consequences into a model that expects a perfect loop, the counterfactual history loses its coherence. This is why we see those negative weights. They are the visible sign of a model looking at a subject that has already been changed by history and trying to treat them as if they were still a blank slate. Rather than addressing this mismatch, the academic world has built a Rube Goldberg machine of diagnostic fixes. We now have SUPT bands, wild bootstraps, and split sample estimators designed to stabilize the results. But each new patch is often just a fix for the distortion caused by the previous one. They refine the weights and the confidence intervals without questioning if the underlying model can actually handle the passage of time. It's like Phil Connors learning to play the piano or speak French. He is acquiring impressive survival skills, but he's still trapped in the same repeating day. Refining the geometry of a spreadsheet can make the math look cleaner, But it doesn't change the fact that a static grid cannot capture the movement of a dynamic world. The data from Chu's reanalysis is clear. When we allow for even minor deviations from that perfectly resetting time, the statistical significance of these studies often vanishes. To move forward, the discipline needs to prioritize models that are explicitly designed to account for how history evolves, rather than relying on tools that treat time as a simple index. Political time doesn't stay parallel, and our most trusted models were never built to theorize the way history actually moves. Until we account for that, we're just getting better at playing the piano in a loop that never ends.